the basic definition for the hardness is the resistance of the material against the scratching. So here the hardness property of hardness can be evolved from the resistance against the impression produced on the material by using a standard indenter. So we have several type of indenters. The type of test, we have the different scales also. So from A to V, the 15 different scales also there. So for which we can use the different types of indenters. So we have the ball indenters, it is 1 by 16 inch dia ball indenter, it is 1 by 8 inch dia ball indenter, it is 5 mm dia ball indenter, and we have the diamond indenter also. So we can use the different ball indenters and diamond indenters for different type of materials depending upon the hardness. So we have also the scale which is given in the machine itself, the hardness scale. So against the materials given here in the list, we can choose the scale, indenter, and also the load to be applied, and also the dial on which we have to note down the readings. So in this we have the two type of materials, one is the copper and another is the brass. So we know the brass is somewhat harder than the copper material because the alloy material is always harder than the parent material. So I want to test today the hardness for the two materials. So I have selected the scale for testing this material hardness is the E scale. So for the E scale, we have to choose the indenter type 1 by 8 inch ball indenter, tungsten carbide ball, and the load to be applied on the side of the, it may be shown in the side of 100 kg. That is mentioned here, load selector. So this is the load applying lever, and the dial on which the reading should be noted here is red. So this is the material applicable. We can also choose any type of scales depending upon the material. So this is the dial on which we have to note down the reading. So we have the black dial and also the red dial. So for the E scale, so we have to note down the reading on the red scale. So I will fix the indenter into the machine. So through the slot provided in the machine, and place the material on the platform, the racing platform. So material should be clean. So we have to measure so in this method we will measure the surface hardness. So the surface should be clean, such as should not possess any scales formed. So otherwise the hardness will change. So the material has been finished, the surface finished, and it is to be loaded in the machine. By raising the platform, the material will be loaded. Here you have to give the initial load. So the initial load corresponds to 10 Newton. So by raising the platform, so here see, by raising the platform, I kept the material into the position of the indenter. So the indenter will gently touches the material. Then raise the platform. So the initial load applied on the specimen is 10 Newton, so which can be shown in the dial. So by raising the platform, the dial will rotate so that you may see the dial inside the another larger dial, a smaller dial. So the smaller dial, so the needle in the smaller dial should not cross the red point, and the bigger needle should be positioned in the point 0. So by doing such a thing, the load applied on the material through the indenter is 10 Newton. Then apply the selected load of 100 kg. So by pushing the lever on the back side of the machine, so the load will come onto the indenter. So by means of the penetration, so we can see the depth of penetration is proportional to the hardness. If the hardened material, the depth of penetration is less. If the material is soft, it have the more depth of penetration. So the depth of penetration is seen here by moving as the dial is moving in the backward direction. So when it ceases to stop, when it stops, when the needle stops, again bring the lever slowly into the original position, that is unloading it. So the needle come back, gives you the Rockwell hardness number. So the dial on which we have to read note down the reading is red. So on this red, it is around 60. So the hardness here is 60. So this is the material is for the copper. So we can go for 2 more trial or 3 more trial. If the number of trial is more will be the accuracy of the hardness number. Then similarly, we can perform the hardness test, the Rockwell hardness test for the another material, brass. So do the same procedure. So fix the material on the working platform. So raise the platform until you may apply a initial load of 10 Newton, so that the smaller needle should not cross the red pointer and the bigger needle will be at the 0. Then apply the selected load of 100 kg by pushing the lever on the other side. So the load will be applied through the mechanism to the indenter. On the indenter, the load of 100 kg is acting on the indenter. So upon acting of the load of 100 kg, the indenter will penetrate into the material. The penetration will be shown by the rotation, the backward movement of the needle here. So the depth of penetration, as I told, is proportional to the hardness. So the needle moves and it stops, then unload it and note down the final reading of the hardness in the same D scale. Here you may show the needle shows around 93.